Okay, let's kick off and as people join. So good afternoon, everyone. Welcome to Tales in Tech Live and the latest installment of Engineering Insights. I'm Simon Evans, a director at Burns Sheehan, and I head up the software engineering function here. Delighted to introduce today Mauricio Salatino, principal software engineer at Camunda, an instructor at Learn Kubernetes, and an all-round Kubernetes expert. He'll be talking about orchestrating microservices in Kubernetes using Zeebe. He'll be very happy to answer any questions you might have at the end of the talk, so please use the available Q&A function. Mauricio, over to you.
Thank you very much, Simon. Let me share my screen and let's get started with this. All right, so let me add this into slideshow. Okay, so during today's presentation, I will be talking about building cloud-native applications that runs on top of Kubernetes. Oh, so this is going automatically for some reason. Just give me a second, So that's not the idea of doing this, but let's do it again. Let's do full screen instead. Okay, so I will be talking about building applications that runs on top of Kubernetes. This application tends to be distributed. And I've been working with different companies just that are going through that change of having a monolith and transforming that into a cloud native application. And when you go through that journey, you kind of like tend to learn a lot of lessons. And that's basically why I'm here. This presentation today, it's a little bit more specific. It's about orchestrating microservices. We will be talking a little bit more about what that means. And I will be showing a tool that it's called Zeebe. That it's a tool that I've been working on as part of my daily job. So my name is Mauricio Salatino. As Simon mentioned, you can find me in Twitter at Salaboy as well if you want to follow me there and follow what I'm working on. But most importantly, I really love solve challenges. I really love to tackle different challenges and design solutions to help people to be more efficient, right? Like to help other developers and other engineers to be faster building tools for these amazing infrastructures that we have today in the cloud and on-prem using Kubernetes. And I think that that's the main reason why I ended up working in Camunda and working with Zeebe. So part of the reason for this talk is just to share some tools that can help you to save time. In the last 12 years, I've been working with different open source projects, and I was super lucky to start my Kubernetes journey pretty early on, almost 5 years ago, when I was working for Red Hat. We started looking into how to move these Java frameworks into a cloud native approach. And that takes kind of like a lot of effort and a lot of, again, like lessons learned that I keep sharing with different projects and joining different communities. Lately, I've been working a lot with Knative and Jenkins-X and Tekton in order to provide more efficient tools for us as developers to build and release software more efficiently. As part of working in the open source communities, I met awesome people, and I wanted to use this opportunity to thank Matthias Cruz, who helped me to build the application that I will be showing today and to make the application more awesome. And by doing that, he's learning how to use all these technologies and how to make software better for the cloud. So thank you very much, Matthias. I really appreciate your help. If you're interested in helping me out with building these tools or building these examples for everyone to use and consume, please get in touch at the end of the presentation. I will be more than happy to connect you with Matthias and myself and guide you through the things that we want to implement in this application. Before I start showing the application, I wanted to basically say that I'm running this application in a remote cluster that is running inside Kubernetes. There are a bunch of containers running. They are all built using Java. I'm connecting to different cloud services using secrets. I'm using my Wi-Fi here and my laptop to run some commands. So what can possibly go wrong? I would say everything can go wrong. And if just one thing can go wrong, it will go wrong. And if that happens, I will just try to show how I've solved these problems like in my daily work and just try to, fix it basically live. So I bet that you all remember some time ago when we used to go to these big, large conferences where, you meet all these amazing people and, go and see amazing talks. Well, that's not the case anymore, but I use that scenario in order to build an application to be able to explain some of the points of this presentation. And all the source code all the application that I will be running and the source code associated to it, it's in that GitHub repository there. Feel free to check it out if you want to run this application in your own clusters, basically. I am trying to update that repository to contain like a workshop style guide on how to run this application. So if you are interested, in participating or running the application and you have feedback about it, please get in touch. So again, if you are running a conference, you need to have some kind of platform to organize who is speaking, when, the sponsors, selling tickets, and all this kind of stuff. So I took that as an inspiration to build the following application that I want to show now. So imagine that you have a conference like Spring One that was pretty good conference. Overall, it's one of my favorite, and something that you will see in these kind of conferences is that you have a lot of people checking the agenda at the same time when the conference starts. But even before that, you need to provide a platform that allows the conference organizers to accept proposals for different speakers that are suggesting different topics and receive those proposals and then just make a decision if the proposals are relevant enough for the conference or not. So in this case, what I have here is the agenda. So if you go to the application that is running in a Kubernetes cluster, you will see that I have an agenda here. 2 days, 4 talks are already approved and are going to happen during this conference. But you as a potential speaker can submit new proposals, right? So let's say something like Microservices advanced, right? So let's say that I'm the author. That's my email and a new proposal. Right, as a potential speaker, there is not much that you can do that sending the proposal itself. And the next step is that you will probably be waiting for a response from the conference organizers to decide if they approved or rejected your proposal. So the next thing that we can see here in the application is that we have a back office for the conference organizers to approve or reject our presentation. Let's say that they accept my presentation here. I will just click accept there. It was accepted, and that should be here in the agenda now. So if they accept my presentation, it will pop up in the agenda. And as well as popping up in the agenda, I just want to be notified as speaker that I was accepted for this conference or not. So what I'm going to be showing here is just the tail for the email service that is basically telling me, yeah, I was accepted, that was my email. And my presentation that was called Microservices Advanced was approved for this conference, right? So I got an email after that. So that's pretty much kind of like the application, what the application is doing. That's kind of like the use case that I will be talking about during this presentation. And I will be covering different angles for implementing this thing. So if I ask you, how would you solve, how would you implement this scenario, right? Like what kind of tools could you use? How would you architect this application? You probably can come up with 100 different ideas and different tools that you can use in order to implement that. I've created just a simple, very, very simple architecture. And again, I was looking, when I built this application, I was looking into make sure that I'm covering the entire journey from having a monolith that was implementing these features into moving this into a more cloud native approach. And again, I didn't work for a conference organization before, but I'm trying to bring all my experience from different backgrounds into this application because I noticed that it doesn't really matter what the domain of your application is, you are going to face pretty much the same challenges all over again. So I'm just trying to share, common solutions for the challenges that you will face. So basically, I decompose the application into the following microservices. And something that you will probably know already is that when you have a cloud native application with multiple services, the last thing that you want to do is to expose all the services to your clients, right? So usually what you do is you have some kind of like entry point for your application, right? So if you have a web application, you want that the client-side code that it's running in a browser, it's just pointing to a simple service. In this case, this entry point that I'm calling API gateway, that is also hosting the user interface. So this component will become some kind of router that will allow to receive requests that then are going to be forwarded to all the backend services. Then I have a call for proposal service that we'll look into more detail later, an agenda service that it's just holding the agenda items. So if you want to query what's coming next in the conference, you're going to hit that service basically. And then an email service that it's basically abstracting, an SMTP server that we want to expose using REST endpoints basically. So this is just kind of like a facade that it's going to delegate to the server, but at the same time, it's going to expose some REST endpoints that I can use in order to send emails, just to make our developers' life a little bit more easy. You can build this application and connect all the services using REST calls. That's pretty standard if you want to do that. And as you can see, each of these pieces have a couple of icons here, like different project logos that you will probably need. And we will be talking about that in a bit. But basically, if you are running inside Kubernetes, you need to find a way to create containers from your services so you can run them in Kubernetes, and Kubernetes can orchestrate these containers. And then I'm listing here Helm as well, which basically, if you don't know and you're using Kubernetes, you should be taking a look at, mostly from the angle of how do you package, Kubernetes application, how do you distribute those applications into different clusters. So again, if you go to that repository, you will find out all the examples for all these things and how I'm using all these technologies together. So pretty simple. I will not dig deeper into Spring Boot. If you are building microservices, there are like a lot of chances that you're using Spring Boot if you're running in Java. If you are using any other language or any other tooling, that's fine, as soon as you know how to create REST endpoints and integrate with databases, connect to databases and NoSQL databases and all these things, you will probably want to standardize in a single framework. So all your developers and all your services pretty much do the same things in the same way. But more importantly than a single microservice, I'm always interested in the set of microservices. And for that reason, I do believe that the Spring framework, it's a little bit on the front side of frameworks, because they have what they call a Spring Cloud, which is a bunch of components that are following cloud native patterns and promoting these cloud native patterns to simplify how do you implement these patterns into real life applications. So if you haven't checked Spring Cloud, I would totally recommend you to check it, because they will save you a lot of times and they will provide you tools that you will probably need to build on your own if you want to start from scratch. And one simple example that I want to show here is that gateway component, right? There is something that is called Spring Cloud Gateway, which is basically an extension for your Spring Boot application that you can add to your application, and you will transform your application into an HTTP router. And by adding the gateway in there, you can quickly configure this component to accept requests and forward requests to other services, right? And this makes it the perfect point to integrate with single sign-on, for example. So when your user hits the service, JSON Web Token, it's created and then it's forwarded with the requests that are coming and going to the different services. So you start thinking about problems across multiple microservices instead of what's happening inside each microservice itself. Spring Cloud Gateway also integrates with something that is called Resilient4j for implementing client-side circuit breakers. And in this case, it allows me to create some kind of fallbacks. If a service goes down, I can have some control on what I'm returning to my users. And I want to quickly show how this gets done, just to make sure that you see like a concrete tool and how it's being used for this particular example. So a Spring Cloud Gateway, it's just added to my dependencies in my project, and then I add another dependency, which is the circuit breaker implementation with Resilient4j. And then I just go ahead and create some routes for my services. So basically this route is saying, if I'm hitting the API gateway, on top of that /agenda/, I will be forwarding this to a Kubernetes service that it's called like that. All right. So again, I'm here using Spring Cloud Gateway to route request, to rewrite request and forward request to different services. And I'm using the Kubernetes service discovery mechanism to just figure out which container is providing an implementation for that service. On the bottom half here, on the filters, I am enabling the circuit breaker functionality, which basically allows me to say, if I'm sending requests to this service and this service is returning something that it's different from a 200 HTTP code, which is everything okay. If not everything is okay, I will be calling a fallback URI here that basically will be executing in the case that I cannot reach that specific service in that case. So if the service is failing, I can basically define what I'm going to send back to the client that it's originating the call. And that's pretty useful just to make sure that users doesn't get an exception in their face every time that one of our services fails. So that's pretty interesting and pretty easy to create and declaratively specify how many routes you want and how to connect different services together. All the rest is being done by Spring Cloud Gateway. All the writing the request and forwarding requests to different services is done automatically. So that's on the Spring Cloud side. There are a bunch of other components that are pretty useful, so you should check them out. I totally recommend you to do so if you're building these kind of applications. Again, they are trying to solve cross-cutting concerns across multiple services instead of just focusing on a single service. But this presentation, as I mentioned before, it's not about all these tools and all these frameworks for building applications. It's more a little bit about orchestration and orchestration in the sense of defining and deciding what's the flow of calling different services from inside of our service in order to accomplish one of these use cases. So I will be reviewing this flow as I showed before in the application. So let's say that this is basically what I showed before. There is a potential speaker in one sending a proposal. That's going to hit the call for proposal service. Then there is a group of people reviewing those proposals, accepting or rejecting them. If they accept the proposal will be sent to the agenda, like the topic will be published to the agenda, and that will be part of our conference. And no matter what happened, if we get accepted or rejected, we need to make sure that we send an email to the potential speaker, right? Saying you were approved or you were rejected, right? And that sounds quite simple, right? That's pretty sounds like what I would do, how I would implement this use case end to end, right? And it's pretty clear to me that if I look at this service here, like the call for proposal service, it's hosting the logic and the sequence of how and which services needs to be called, in which order and in which circumstances, right? I need to say, if it was approved, I need to call this. And I'm bundling all that logic inside this service, which makes a lot of sense because at the end of the day, this service is the one that is in charge of defining how do we deal with calls for proposals in this case. So let's take a look at the code for implementing that, which is pretty simple, but I just want to show it so we can discuss a little bit about how can we improve these kind of things and how does it look like for this concrete example. So basically what I'm looking at here is the call for proposal controller inside the call for proposal service. And this controller is basically exposing two REST endpoints that are super important. The first one is the new proposal. So every time that somebody sends a new proposal, we get the proposal and then we store it in the database, right? Pretty simple, pretty straightforward. And then we can emit an event, depending what kind of architecture are we building. We would probably want to notify other services that we just received a proposal. But the most important one, in my opinion, is this one that it's called decide, which basically holds the logic of what to do when a decision is made. So in this case, we get a request here, making a decision if it was approved or rejected. So this is when I click the button, approve or reject. I will get a call, a request to this endpoint. And basically, the first thing that we will do is we'll fetch the proposal by picking up the ID from that decision and getting it from the database. If the proposal exists, we will change the status of the proposal to decided, and then we will apply that decision, right? Here, like approved, we'll have a flag saying if it was approved or rejected. Then we will store this into the database. And then here is where the logic begins, right? If it was approved, I need to call the agenda service, in this case, to create the agenda item. And it doesn't matter what happens, I need to send an email to notify the potential speaker about the decision, right? As you can see here, I have like 20 lines of code, no more than that, right? Like that's pretty simple. But of course, here inside, you might be wondering, what is this agenda service doing? And as I mentioned before, this is pretty simple. It's just doing an HTTP request to the other service, right? So if we take a look at this, it has some bit of logic here on deciding when is that talk going to happen. But then at the end, I'm just using REST template to send a post request to the downstream service, in this case, the agenda service, right? That is there. Again, I'm inside Kubernetes, so I can use a name in order to interact with that service. Pretty straightforward, right? Let's go back to the presentation. So that's pretty straightforward, right? And I would assume that because this is an example, the source code will look simple, right? But in real life, that's never the case, right? Like we have daily pains with these kind of things. Because in real life, that source code that was 20 lines of code will be 1,000 lines of code. And if somebody that it's not from, like not the developer comes and asks you, how is the application working for these cases? You will need to go and dig into the code in order to understand exactly which services are called, in which order, under which circumstances. And that's not simple if you start adding edge cases and unhappy paths, right? What happens if one speaker disappears, or what happens if if we don't hear anymore from this person, or if we lose track of one of our proposals, right? How do we deal with that? What happens every time that someone comes from the business side and asks us, okay, but now we need to change the sequence, we need to add these other things, and we need to call these other services, and now we need to integrate with Salesforce or an external system in order to make sure that we keep track of our speakers. And I guess that if you're working in real life applications, 90% of the time, these applications will have some kind of time-based constraints or actions, right? Like send notifications after 3 days of something happens, or run these things every Monday, or that kind of stuff, right? How would you solve that in these kind of architectures, in these kind of like distributed applications? Finally, implementing queries and analytics, it is a thing, right? As you can imagine, when you build applications like these ones, each of the services will store the information in the way that they need in order to run the conference, right? So the data that you're storing and in the shape in which you are storing the data is not optimal for running queries and analytics, right? Because again, that data model was defined for running the application and running the services, not for running reports on top of it. So you will need to figure out a way of externalizing data from all these services and pushing that into storage that can be, more efficient in running these operations. For conferences, maybe it doesn't make much sense, but imagine that you are implementing a shop or like some kind of shopping where you can just buy a lot of products in short periods of time. So imagine Amazon creating a lot of orders in a minute. At some point, you will need to organize this data in a way that you can basically get reports on how many items are being bought every minute, that kind of stuff. So think about how would you tackle all these challenges in order to make your daily life a little bit more easier, right? Like every time that somebody asks you for a change, you don't push back, you just go ahead and implement that change without thinking too much about breaking everything. So my question to you is, how would you tackle these challenges? And again, there is no single way of tackling these challenges. There are like different solutions for each of these problems. But what I wanted to show today is this tool that it's called Zeebe, that it's basically a workflow engine that was designed to run on top of Kubernetes in a cloud native way. And the main purpose for this is just to provide orchestration for events and microservices. And we will be looking at how it works in a bit, but currently it's available as two kind of like shapes. One is you can run Zeebe inside your clusters, your Kubernetes clusters. You can deploy these alongside your applications, or you can use a managed service, like a software as a service approach that it's called Camunda Cloud, that it's going to run these components for us. And that's the one that I'm using for today's presentation, right? I didn't want to install anything in my clusters where I'm running my application. I just want someone else, in this case, Camunda, to run this service for me and provide the automation for my workflows that I will be showing now. So when you use a tool like this, basically what you do is you create a model of the flow for the things that needs to happen. That's what we call usually orchestration, defining the sequence of service that needs to be called, what's the order, and what are the circumstances where we need to call these services. So in this case, the architecture looks a little bit different as it looked before. So instead, the services communicating between each other. Now they are delegating these communications and the sequence of these communications to Zeebe and to this model. So I created this model here. It's something that you can create with a tool that I will show later on. But basically, this model is saying every time that this service, the call for proposal service, receives a new proposal, we will store it in the database in this service, but we will also start a new instance of this model. And that instance will move the proposal through these different boxes, basically. The first box is waiting for a decision to be made by the committee, right? So we will wait for that. And of course, this is the service that is exposing the endpoint where the decision is made. So when the decision is made, this service is going just to connect to that model instance, and it's going to move this flow forward, right? Based on the decision now, the flow has the responsibility of deciding what to do. If it gets approved, we will call these services. If it gets rejected, we will call, we would just send an email in this case. And then the model will be in charge of connecting to the services and executing whatever logic needs to be executed for like achieving those actions like publishing to the agenda, right? And again, if we were doing that before via REST, now we can like invert that a little bit, and we use a PubSub mechanism here to send messages to these services back and forth, which enable us to build more robust applications where we have retries and we can deal with incidents in a better way. So we will be looking into that a little bit as well. One more thing about Zeebe and this architecture is now we have this component that is running these models, and because we have control on how these models and how these flows are being executed, and when these things are happening, we can send all that data to Elasticsearch. So we have it already in a shape that can be used for reporting and for doing analytics, which is something pretty useful. As you can imagine now, if you have a model like this, you can explain what's happening inside the application to any person inside the company, because this model is pretty understandable, right? We set a new proposal, a decision is made by the board, we can just add more details in there, and then based on that decision, things will happen, right? And I can clearly explain to other people what's going on in our applications, which is something pretty good. Let's take a look at how is this running in real life. And basically what I want to show here is a tool that comes with Zeebe, and that also comes when you create a cluster in Camunda Cloud, that it's this managed service. And what we can see here is that model that has been deployed here. And we can see already, like quickly, how many proposals have we approved and how many proposals have we rejected. I can refresh this because this is old. So I have 5 proposals approved and 2 rejected, which is pretty much reflecting what we have here. 5 approved. And if I go to the back office, I can see that I declined 2, right? So without much, I can just give this, this tool to my managers and to my stakeholders to say, okay, let's take a look in almost real time. How many proposals do we have in flight and how many proposals are already completed, right? So for every new proposal that I create, I will see here in which step that proposal is, and we can just go and do that now. Let me go and create one new proposal. Test proposal. Let's reject this one. This is a test, right? So I will send that proposal. The submission is sent, and at some point here in the backend in this tool, almost it's not real time, but almost real time. It's like eventually consistent. At some point, I should be able to see that that proposal is there, waiting for a decision to be made, right? Again, I can just jump into this screen and just automatically understand what's the status for the day, right? That's the first thing that I can do when I just go to the office, see my dashboard and said, okay, this is what I need to do today. There are like 10 proposals waiting for me to approve or reject, right? So if I go and reject that proposal now, you should be able to see that that proposal gets rejected. And if I drill down in there, at some point, I will just see that the proposal is being rejected, sorry, this path, right? Also, because again, we are delegating the execution of this model to the workflow engine, we have like traceability on what things happened, with which data, and at what time, right? So we have like end and start time for all these things, which can also be used to calculate analytics. For example, we can analyze how much time does it usually takes to make a decision, and based on that, we can hire more people to make more decisions faster, or to try to automate that decision as well, right? Depending on what kind of data are you dealing with. So that's pretty much what you can do with Zeebe on the basics. Now you are delegating the orchestration of these services to someone else. The delegation, the definition of the flow still belongs to the call for proposal service and for the team that is responsible for that. But the execution of the model now it's happening in a separate service, in a separate component. So the next step that you might want to talk about is like, okay, now you want to make changes, right? How do we do it? Because again, being able to make changes into your application and into your services, it's an important part of being able to move forward and make sure that your business can, adapt to changes in the business reality, right? So you can just go ahead and do changes instead of pushing back and saying, no, if we want to make that change, we need to, re-architect our entire solution. So let's imagine that we want to implement this change. This is a little bit different flow. In this case, we don't want to publish, one of the proposals to the agenda unless the speaker that is in charge of that proposal commits to present in our conference. In order to do that, we change the sequence. So instead of publishing to the agenda, first we will send an email. If the proposal was approved, we will send an email to the speaker saying, okay, fine, you were approved, but you need to confirm that you are willing to participate and you need to commit to do it. And by that, we will be adding a link here for the speaker to confirm its participation to the conference. And as soon as the speaker confirms the participation to the conference, then we will publish that to the agenda, right? So again, similar flow, but now the sequence is different. Remember that usually this team and this service is responsible for making that change, but now because we have a model, we can just go ahead and change the model itself. So if you take a look at what we call Zeebe modeler, which is basically where we can create these models and deploy these models, we have this tool that basically allows you to drag and drop and create these models to represent these situations. We can just change that model. Remember here, before we were publishing to the agenda and then sending an email if we were approved. Now I have a different model that basically implements the changes that I just mentioned. After the decision is made, we will send an email that now will include a link for the speaker to confirm. We will wait for a message from the speaker to confirm. When we get that message saying, yep, I commit to presenting your conference, then we will publish the item to the agenda, right? And basically what I will do here is I will just submit this to the cloud, and I will deploy this new version of my model. And if I go to operate, which is again this tool, this dashboard tool that allows me to see my flows, I will see that I have a new version for my calls for proposals service. This is version 16. I've been testing this for some time, and that's pretty much the new version, right? And again, I've configured my application to use the latest version all the time, right? But you can do A/B testing, and you can add more logic into your application to say which exact version of this model it should use, which allows you to say, okay, for these customers or for these speakers, we will use the old version, and for new speakers, we will use the new version, for example, right? So I've just deployed this, it's live into the cloud. So if I create now a new proposal, it will follow these steps. It will not follow the model before. Again, highlighting the idea of now you have a tool where you can explain quickly how the application was running yesterday and how the application is running today, or multiple paths at the same time, right? Like you can be using both versions at the same time for different purposes if you want to. So what we can do now is I can go ahead, let me put this full screen, and I can go ahead and create another one. So proposal with link. And this is again the link to confirm. So that's me. Test link in confirmation. Let's say something like that. So I've submitted that. I can go to the back office to see that this was submitted. And remember that I need to accept it in order to send that email to the potential speaker. So I will accept that. You can see here that we should have a new instance. And that instance probably is going to send the email, and now it's waiting for the confirmation coming from the speaker. So if I switch back here to my terminal where I'm telling the log for the email service, basically now I have a link here that I can submit the request here just to commit to present during this conference. And you can see here that I'm using the proposal ID in order to relate these things, right? Like correlate and aggregate these things. So I'm just sending the request here. I know that the font here is small, but that's basically a confirmation that I just interacted correctly with that endpoint. And at some point, I just see that this was published to the agenda, and I can go and check here that test with link should be somewhere there. Proposal with link, it's there, right? So again, I just changed the flow of the application by just changing the model, and I'm delegating the decision on which services to interact with to the model now. It's not buried inside the service, the service source code. So I can just change that, and I can expose those changes, and I can share those changes with more people that I could do before, right? Because now it's not just a technical thing, it's the model that it's a little bit more declarative, and it's a little bit more understandable by other people than developers. So back to the presentation here, just for the last point. Yep, so I can just change the flow and just show that. And notifications, again, 90% of the time when you're building real life applications, you need to implement some kind of notifications and alerting system, right? So in this case, let's say that we want to provide some kind of service level agreement with our potential speakers. We want to say, after 3 days of you submitted something, we should come back with a decision, for that, right? And in order to achieve that, basically what we can do is we can start registering notifications to make sure that the committee gets reminded that they need to review these things in the in the time of 3 days after receiving the proposal. And again, that's per proposal, right? Like it's as soon as the proposal arrives, you have 3 days to make the decision. So we will be registering notifications for that case. And again, this basically means that you can add a change to the model. I have another version here of the model that it's basically adding this little thing in here, which is a timer, which allows us to schedule operations to happen in the future or like repeat in repetition over a cycle, right? So you can use an ISO standard here to define how often and how many repetitions do you want. And that's going to basically trigger, actions at that time. In this case, I'm defining 5 repetitions over like periods of 15 seconds. So we can see something now, not days, just seconds. And basically this is the action that it's going to be executed. In this case, an email notification to the committee. So that's pretty much what I will do now. I will just upload this version of the model. Now this model is live. And I can go and check it into here again, operate. I should be able to have a new version now, version 17, that basically has this new timer functionality in there. And again, the only thing that I did is just drag that node that it's a timer, and then I configure which action do I want to execute every time that this timer gets triggered, right? So let's create one example with that. So testing notification. All right. Yeah, so I'm just sending that proposal. And again, I will not go and complete it right now because again, these notifications should happen every 15 seconds for the proposals that are not being reviewed by the committee, right? So let's wait a little bit until it pops up here, and then we can drill into the instance and see that after 15 seconds, we will just get one of these notifications that we can also see in the email service here. Right, so after the first 15 seconds, we get a notification sent to the committee saying, please review this proposal with this ID by this author, right? And after 15 seconds, again, we get the second notification, right? And this is so common. This is such a common requirement that almost every application will need this. So we make it super easy for us to build, just dragging that to any node, and we will just create notifications. The good thing about this is that those notifications are going to be triggered only when this task is still pending, right? If I go and complete that, right? If I go and complete that, that notification is not longer needed because we moved forward. So that timer and all these notifications get garbage collected because they are not needed anymore. So think about that and think about how much time could it take to actually implement this in a distributed application. Like implementing distributed timers in a distributed way will push you to have a component that needs to be highly available to make sure that you don't lose these timers, because the last thing that you want is to lose these timers, right? Like you want to set these notifications, and even if all the services are going down, those timers, whenever the services come back again, those timers needs to be executed at the right time, right? So Zeebe, in this case, the workflow engine is taking care of all these things because, again, these are such common requirements that we are trying to make it easier for you just to leverage that. And let's switch back to the presentation. And I think that there is just one more thing that I want to say. That's not it. Where is it? Here. Here. And finally, one last point that I think that it's important. It's about dealing with incidents like a pro, right? We want to see things going red if if services are not working, or if we are not being able to handle this use case like from end to end to a user. If something breaks in the middle, if a service is breaking that it's not allowing me to complete the use case end to end, we need to make sure that we are aware of that. And of course, if you are building cloud native applications, you will have, for sure, you will have tracing and you will have logging. But usually these two things, tracing and logging, are super low level and they are pretty technical. They are for technical teams to understand what service went wrong and how and what's probably the technical problem. But we also want to make sure that we propagate these issues to to other stakeholders. Let's say the HR department or someone that is interested in understanding or getting in touch with the speakers personally, right? When any of these problems arise. So imagine that we can just run all the services, but the agenda service is failing. So we cannot publish to the agenda, right? And making sure that we don't end up in an inconsistent state, it's pretty important in these kind of situations, right? We don't want to send an email to a speaker saying, yeah, you were approved for this conference, but we never show the proposal in the agenda, right? Because that's the worst thing ever, right? So we need to make sure that we don't end up in situations like this. And for that, like again, Zeebe and using these models can help, because again, it's such a common requirement that Zeebe and the workflow engine is automatically implementing that for yourself. So for example, I have a payload here that I can send to a proposal just to make it fail. And in this case, fail. And the title, right? Making it fail. So if I send fail in the title, this is going to make the agenda service fail. And I just wanted to show that to basically share that idea of, okay, let's accept this, let's make it fail, but we want to make sure that other teams are also aware that things are going wrong. So for example, if I go here, yes, I already have an instance that it's failing, and it's basically saying, well, this service is failing. I do not know what's going on here. I can drill down and see what the problem is, right? I can take a look at what the incident is and say, okay, what's wrong? So an error, that seems to be like a pretty technical error. So I will definitely need to get that information and send it to the technical team to see if they can fix it up. But something important is that because I'm running now this model here, I'm looking also at the data that it's been handled by this instance, and I can quickly see who is the author of this presentation. So I can get in touch outside of the system and say, okay, something is going wrong. That's why your presentation is not published in the agenda just yet, but we're going to sort it out. And in this case, the engine allows me to also change data here. So I can just work now. I can just change the data, apply that change, and then retry the action from here, right? So this is not for solving technical problems, but this at least gives you an idea of how many incidents are you having, how much time it takes to solve these incidents. And sometimes when you can fix the incident, you can even retry from here, right? So if I retry now with the payload that will work, it will just complete that instance and problem sorted, right? Again, not to solve all the problems from here, but at least it gives you an idea from like a high level perspective on when things are going wrong, where are we with each of the flows that are running, right? We can again have a clear picture of how many things are happening. And by using that, we can externalize that to other teams and to other stakeholders that can use this information to make better decisions. So let me go out. It's complicated to here to find things. Let's move forward. So that's pretty much it. Just to close some remarks about this, right? Like about the things that I've been showing. So when you're working in happy organizations, you will keep having some of these daily pains, but with these tools, we are trying to make your life easier, trying to make sure that not only technical teams understand what's going on and how the applications are working and what to do when things go wrong, but also to externalize that information to other departments. We want to make sure that we build these cloud native applications in a way that allows business to require us to change stuff, and that we don't have excuses to push back because the changes are too complicated, but we just can quickly adapt and create these changes and push them to production. And again, the main idea here is that just to open in a little bit the scope of saying, yeah, okay, we can collaborate between different technical teams, but we are also including non-technical people to collaborate in the definition how our applications are working. Finally, this is one of the examples that I built. Again, you can run this in your own cluster if you want to go deeper into the technical aspects of this example. And I will be presenting another example that I've been building that it's more event-driven and using Kafka and Knative this Thursday. And I'm doing that for Linode and LearnK8s. That's the URL for that presentation if you want to register. Also, Salman from LearnK8s is presenting a deep dive into the Kubernetes scheduler, which is also an interesting talk. So feel free to join if you're interested in those topics. And of course, now I'm happy to answer any questions regarding the presentation, the webinar, or any other tool that I've mentioned during this presentation, or that it's included in the examples. So I will leave this one on, and I will keep sharing. But Simon, if you are still there, feel free to jump in.
Indeed, I am. Well, thank you very much, Mauricio. That was awesome. I know people always enjoy the live demos, the pressure you put yourself under by doing that. So just give it a moment, see if there are any questions. But I think, as
Sure.
often is the case, when you've demoed it very well, it seems fairly simple and self-explanatory. So great work.
Thank you.
So
should I stop sharing my screen, or do you want me to keep it on?
No, I don't mind. I don't think anyone needs to
Good.
see me any larger, so that's absolutely fine.
Great.
Any questions? Oh, no, we just got someone saying great presentation, so that's good.
Thank you very much. Feedback is appreciated. And again, I am collaborating with some other people to improve this application. So if you are interested in some mentoring or just helping, or just getting your hands dirty with these technologies, just feel free to reach out. I will be more than happy to introduce you to the code, and we can work together on something cool.
So Mauricio, we've got a question come through from Andrew. Hi, Andrew. The question is, what technology supports the pub sub?
Yes, so the pub sub in this case for Zeebe, it's using gRPC. So it's basically a native stuff inside Zeebe, but we're working on expanding that. And I have in the presentation that I'm doing on Thursday, I'm doing the interaction between different services using cloud events, using Kafka as well. So there are some kind of like bridges to integrate with that pub sub mechanism that it's happening inside Camunda Cloud, which is this hosted service. If you run it on your own, you can integrate with Kafka, or you can integrate it with cloud events or RabbitMQ or whatever you want. Hopefully that answered the question.
Perfect. Anything from anyone else? Yeah, that answered what Andrew wanted. Well, I do know that Mauricio is very happy to answer any questions you might have. You can contact him directly. His Twitter handle is actually Salaboy, as per his pseudonym on LinkedIn too. So I say, Mauricio, thank you very much for that. Much appreciated. A really interesting demo. Thank you everyone for attending. The video of this, and indeed the rest of the Engineering Insights and Tales in Tech webinars, are on the Bernd Sheehan website and YouTube page. Naturally, if you do have any topics that you'd be interested to hear more about, or indeed would like to present at these, please do let us know. Speak with myself or our community manager, Becca. We are always keen to hear from our community and provide the sort of content that they want to hear. So that's it from another great session. Mauricio, thanks once again, and see you for the next Engineering Insights.
Thank you. Bye-bye.